Let us see how to find marginal cost from the given production function. The question is, a firm has a production function that is y is equal to k to the power 0.5 times L to the power 0.5. K and L are the capital and labor, y denotes the output, and faces a wage rate of that is W is equal to 4 and a rental rate of capital that is R is equal to 4. We need to find out the firm's marginal cost. Okay, so what we are being given? We are being given the production function that is y is equal to k to the power 0.5 L to the power 0.5. Okay, also wage rate is being given us as 4, rental rate of capital is also being given us as 4. We need to find out the marginal cost. Okay, how do we solve this kind of question? Simple thing. What we do first, let us see what will be the total cost of the firm. Total cost will be equal to wage rate times units of labor employed plus rental rate of capital times units of capital employed. This is the total cost function of the firm. So our cost will be equal to W is equal to 4L plus R is being given us as 4K. This is the total cost. Now the problem is we want to minimize cost. We want to minimize cost. That is, we want to minimize this cost function subject to the production constraint. And what will be the production constraint? This is our production constraint, that is k to the power 0.5 times L to the power 0.5 should be equal to y. Okay, so what exactly we want to do here? Let's draw the graph. Given, let us say we have labor on this side, capital on this side. Okay, given this isocont, okay, given this isocont, we want to minimize the cost. That means our cost will be minimized where the isocont and isocost lines are tangent to each other. Let us say this is the point where marginal rate of technical substitution between labor and capital is equal to the ratio of the prices, that is price of labor upon price of capital. Okay, now what is MRTS? MRTS is simply equal to marginal product of labor upon marginal product of capital. So marginal product of capital, marginal product of labor means the partial derivative of production function with respect to labor first, divided by the partial derivative of production function with respect to capital. Let's take the partial derivative of this function with respect to L. That means we will get here derivative of L to the power 0.5 is 0.5 will become coefficient. We have k to the power 0.5 and L to the power, the exponent will be subtracted by power function rule, so we will get minus 0.5 divided by symmetrically the derivative of production function with respect to capital. This time we partially differentiate with respect to capital. The exponent of k will become coefficient, again 0.5, and exponent of k will be subtracted by 1 by power function rule, so we will get minus 0.5. Then we have L to the power 0.5. This is our MRTS. If we solve it here, okay, if I transpose k to numerator, the exponent sign will get changed and this k will get multiplied with this k. Okay, so what will we get? We will get k, so 0.5 plus 0.5 will add up to 1 divided by, if I transpose L to the power 0.5 to to denominator, it will get multiplied with this L, and again exponents will sum up to 1, so we will get k upon L. Simple thing, let me explain it here. We have k to the power 0.5 here, k to the power negative 0.5 here. I'm just transposing this here, so it will become k to the power 0.5 multiplied by, if I transpose, it will get multiplied, but exponent sign will change, it will become 0.5. Bases are same, we can add up the exponents. So we will get k to the power 1, we call only k. This is our k, and symmetrically this is true for L if I transpose this numerator to denominator. Okay, so this is our MRTS. So MRTS is equal to K upon L, and we know that this condition must be held at the optimal level. What is price of labor? It is being given as W, and what is price of capital? It is R, and this is also being given us. That means price of labor upon price of capital is equal to, so price of labor is equal to W upon R. W is 4, R is also 4, so this ratio is equal to, if I write this condition, that implies, so MRTS, let me write it here, MRTS should be equal to price wage rate into rental rate of capital W upon R. MRTS we calculated, it came out to be K upon L. W upon R is equal to 1, which implies K should be equal to L. Okay, simply plug K is equal to L into our constraint. Our constraint is this time this very constraint. So in place of K we write L. So we have K, so in place of K I will write L to the power 0.5 times L to the power 0.5 should be equal to Y. Adding up, bases are same, we can add up the exponent, so 0 0.5 0 0.5, when adding them it will become 1, so L will be equal to Y. If L is equal to Y and K is equal to L, that means K will also be equal to Y. Okay, so L is equal to Y, K is equal to Y. Now what we need to do, we simply plug the value of L and K into our cost function. So our C will be equal to, W is being given us, or let us say this is our cost function here, in terms of parameters. So we have our C will be equal to 4 times the optimal value of L is Y, plus we have 4, the optimal value of K is again Y. That means it adds up to 4Y plus 4Y is 8Y. So this is our total cost function, but we need to find out the marginal cost. Marginal cost is simply the derivative of total cost function with respect to output. So if I take the derivative of y will be 1, so we will be left with 8 only. That means marginal cost will be equal to 8.